Hello everyone. So we're going to change this project a little bit so that the floor is rounded using a cylinder. And this will allow us to turn the project into a Fitts law experiment. The Fitts law experiment is an input comparison design where you can test the speed and accuracy of different inputs. To get there, we're going to need to have some more complicated 3D objects than what are provided by Unity. So we're going to add a package called ProBuilder. So we're going to Window, Package Manager, ProBuilder, Install. This will add it to Unity for us. With ProBuilder in your project, we're going to start by adding two shapes. So we're going to go to ProBuilder, ProBuilder Window, New Shape. First one's going to be a cylinder. We're going to set it to 6. Move its transform to 0. Number of sides, if you play with this, it'll change how smooth the object is. And we'll keep a height of 0.5. We'll build it. We'll add a pipe, 6, height, 1 works. We could do 0.5. Thickness, pretty thin, and the same number of sides. And we're going to build it. Pipe we can center. Now we have those two objects. We can highlight them both and then press center pivot, and that should bring them so that they center on 0, 0, 0 instead of having one of the edges act as the center. With these changes, I'm just going to delete what we did last week, and we'll start building up from here. Fitts law requires you to repeatedly select targets. This image shows a pretty typical pattern. The participant would start at 1 and then select 2, 3, 4, 5, and just keep alternating sides. To help us with our setup, I'd like to add this image into our project. So I'm going to download it. And then I'm going to take that and drag it into our project. When we drag it over, we can drop it in the materials folder and we'll see it pops up here. We're going to move it over to here on the cylinder, but that doesn't quite look like what we'd like it to. So we're going to change the shader. We might play around for a minute with different shaders. So it looks like for that image, setting the tiling to 0.1 and the offset to 0.5 kind of lines it up where we want. We can use this now to help us establish what our Fitts law targets look like, and then we can remove it. Before we start adding too much to the scene, let's go ahead and make it a little more playable. So I'm going to go and find the camera and move it around so that I have a clearer view of the play area. This might look best if we center it. Maybe remove that rotation. Just playing with different heights to see the preview and get it lined up somewhere that we think looks good. Now we have this. Which is perfect for us. In the scripts folder, I'm going to make a new folder and call it controls. Then I'm going to add a script and I'm going to call it tilt control. I'm going to go ahead and open that. If we're going to add a lot of packages, sometimes it's nice to keep our scripts in a namespace. So I'm going to add a namespace and I'll just call it tilt fits. We're going to want this to manipulate an object in the scene. So we're going to add a public variable. And we're going to call it platform. Then we'll go back to Unity. Add a empty game object. We'll call it platform. We will parent those in there so that the platform has first we have to zero it. Okay, and now we can add these into the platform, and now we have an empty object that we can rotate, and it'll rotate everything. We're also going to add a tag. Let's manually add a tag for platform, and then we can save it. Now when we go back to here and add it, we go here on start. We want to find the object with the tag of platform, and we'll set platform to it if platform's null. Perfect. We'll go back to Unity. Going to make a new object and just call it controls. I'll zero it, and I'm going to add the script that we just made to it, and we're going to see if it can load and connect. Yep, so now controls is connected to the platform, and we can start working on the actual key bindings. To grab key bindings, we're going to do a separate function. Make it a void. We'll call it on update. We're going to check each frame to see if inputs are being pressed and then do something according to what's being pressed. To get the inputs, we're going to grab some floats. We'll get the first one. We'll call it horizontal. Get axis. And then we need the string name, which is horizontal. And then log, and we'll log the value of horizontal just to make sure we're actually grabbing it. We'll go to Unity. Edit settings, input, horizontal. Okay, so I had the wrong axis. So we'll go to player settings, player, input manager, horizontal, capital H. Replace that. And check again. Zeros. And then if I press D, it goes over to 1, and A is -1. All right, so first we're going to add another float, and we'll call it the degree constraint. We'll set it equal to 20. This is something we'll use to multiply and get the rotation in degrees that we like. And add another float and call it horizontal rotation. That's going to be equal to the horizontal input times the degree constraint times time delta time. If we look, time delta time is the amount that's passed since the last frame. Multiplying it by that keeps this smooth over the frames per second instead of just doing this once per frame. Then we're going to grab the platform, get its transform, and we're going to rotate it. Rotate takes a vector 3 for Euler angles, so we're going to do a new vector 3, and we want to rotate it around the z. We'll add that. This will take a little more work, but we can test to see where we're at now. And we have some rotation. We're going to make a second script to spawn a player. So I'm going to make new folder, call it player, and we'll make a script. It opens. Add that namespace. All right. Saving the scene. Now what do we want the player to do? We need it to spawn some sort of representation and then enable physics. So first we will make a public game object, call it representation. That'll be the object itself. And then a private rigid body, call it rigid body. Go back over to Unity. There is a handful of folders that are important in Unity. One of them is a resources folder. Resources is something that's loaded so that the game can access it without having to call different load functions. Going to go ahead and make a player over here as an empty game object, and then we'll call it player with a tag. And for now, we'll just add a sphere. And then under resources, we'll drop it in. That's now called a prefab. You can see it's blue. And then we'll change controls to just a little more generic manager. Drop the player onto the manager. It says none. We can go over to resources, drop that in there. Then on start, we can instantiate it. Instantiate. Instantiate returns a game object, so we're just going to take that game object and assign representation to that directly, and we should have it spawn when we start. Looks like it did. Have a player over here. Perfect. go back to player, just change this to 0, that to 1.5, that to 0, see where it goes. Perfect, right in the middle. Go back to our script. Then we'll go dot add component, type of rigid body. And we'll set our rigid body to that. Rigid body controls physics. So now we're going to set a couple of things. Dot is kinematic equals false. Is kinematic means it won't respond to joints or physics. So we don't want that. We want gravity. So we're going to do that to true. Then we're going to wake it up. And we're going to add some force to it. Add force. Doesn't really matter a whole lot, just enough to get it moving. Go over Unity and try it out. And now we have the object we're going to use to try to manipulate using these tilt controls to get it across the different points for Fitts law. Okay, so first we're going to move this to the top as a public float. We're going to add a range. To it, and then let's do one more and call it speed. We'll set it at 3 and give it a range of 0 to 5. Down here, I added a negative sign to flip our input, and then we're going to grab the vertical input. We're going to multiply both of those by the degree constraint. We're going to make a new quaternion. And we're going to use Euler angles to make it. And then we're going to set the first one to vertical and the last one to horizontal. And then we're going to take the transform of the platform and we're going to rotate it. We're going to set the rotation to this new rotation using spherical linear interpolation. So we're going to start with where the platform currently is, end with the new rotation, use the time dot delta time to smooth it, and then we're going to multiply that by our speed factor, and this should give us some rotation controls and some access to them. We go over to our input manager, we can see the other inputs we gave it, so we can adjust the speed. And that looks like it's working. Adjust the degree. Larger degrees will move a little quicker. Okay. Next, we're going to add some safeties to the platform just so the player can't accidentally exit it. We'll make one, we'll call it walls. We're going to remove the renderer component because we don't need it. I guess we can disable it if we can't remove it. We're going to set the Y to 5. this up a little, say 1.525, perfect. And now we have some walls. We're gonna repeat that for the ceiling. Take that, get rid of the renderer, move it up, walls, get the physics debug. Call it 2.5. If this works out, we should have sort of a box that the player won't fall out of. Upside down. Yep, and the ball is still in there. So that worked. I'll parent the ceiling and the walls so that they both show up, and then we'll tag them as something in case we need to access that and disable it later. So we'll call it a barrier. Now that we have a platform that moves, I'm going to go back in and change some of the player settings. So we have this rigid body. And we're going to add some mass. This will slow it down. Drag. That will slow it down. And the default's a mass of 1, which should work out. Now when we play it, this player, it's got this drag. And it's a little bit quicker to slow down when you stop moving it now. If we set that back to 0, we can see the difference. Now I'm going to grab some assets from the asset store. Look for some free materials to use. Window asset store opens the store in system, and then you can scroll through it. I selected free ones. Download it. Should add it to my project. Import. It's just showing us all the options. We don't have to import them all if we don't want to. I'm just going to import it. Okay, let's see what those look like. Yeah, so now we can play with these and try to find one that we like to add to our walls and to our character. Maybe the chain fence. And then to add something to our prefab, we're going to go back to our resources folder. Double click on the player. We have this sphere. We can add a material now. We go over to default. We can just tab through them and pick one that we like. All right, I'm going to save that and let's see what it looks like. It's a little bit more fun now. While we're doing this, I'm going to move the game screen over here so that we can keep the scene open and then reverse out of the player. Perfect. I think that on the player, okay. So the last thing we're going to do right now is move our sun up a little and point it straight down. Maybe make it a little less intense. And try that. This is keeping some of the shadows from showing up that were blocking the edges. Next time we'll start working on adding some triggers to see when different targets are passed through.